My name's Chad Westbury. I'm here to talk about a lesson plan involving Fibonacci sequence for a Year 4 class. So first off, we could show them some example pictures like this and ask the students what they think these pictures here have got to do with maths. So it's about the Fibonacci sequence. So a sequence is a list of numbers that run in order. For example, 1, 2, 3, 4 is a very simple sequence. 2, 4, 6, 8 and 5, 10, 15, 20 is another example. So first off, we could get them to do those sequences and work out how to find the next numbers. And then we could teach them about the Fibonacci sequence, which is a little bit trickier. So it is 1, 1, 2, 3, 5, 8, 13. So to get the number 2, you add the two numbers before it. So 1 plus 1 equals 2. And this sequence keeps going. So to get the number 8, you add the two numbers before it. So 5 plus 3. So to get the next number on the sequence, you just add the last two numbers, which is 13 plus 8. And then we could get the students to find a couple more of those numbers of the sequence. We go explain that Fibonacci's numbers, his sequence, are everywhere in nature. For example, some fruit grow in the sequence. This one's got 3 sections, which is a Fibonacci number. This apple has 5 sections, which is also a Fibonacci number. Even your hands grow in Fibonacci numbers. For example, you've got 1 thumb and 1 thumb, so that's 1, 1. You've got 2 bones in the thumb. You've got 3 bones in your fingers, 1, 2, 3 in all your fingers. You've got 5 digits on each hand, and you've got 8 fingers in total, which are all Fibonacci numbers. Even flowers grow in the Fibonacci sequence. So that one had 1 petal. This one has 5 petals and 2 lots of 5. For example, this one has 3 petals and this one has 2 petals, which are all Fibonacci numbers. And pine cones are amazing because the number of spirals in the pine cone always add up to a Fibonacci number. So we could get them to count out these spirals and we can see if they're a Fibonacci number. And then we can check them to spin spirals the other direction, see if they can count them, see if they add up to a Fibonacci number. Same with sunflowers. See the spirals? They always add up to a Fibonacci number, the number of spirals. For example, we get them to count this one. So anti-clockwise there's 55 spirals and clockwise there is 34 spirals. So then we could go outside and get the students to look for flowers and count how many petals they've got and look for spirals and seeds and whatever they could find. So once we come back in the classroom, we can show them this puzzle here and get them to cut out these squares. We get them to colour in first maybe. And what do these squares have to do with Fibonacci numbers? We could ask them. And then starting from the small squares, we can ask them, can they put them together so every time they add a square, they can create a rectangle. So for example, they could add the two small squares, that makes a rectangle. And add the next small square to make a rectangle. And then, what does this spiral have to do with those squares? So then once they've put their squares together, we can hopefully get something looking like this. And then we can show them this spiral here. And this spiral here is the same as a lot of things in nature. For example, this galaxy works on that spiral. Your fist works on that spiral. A snail shell works in that spiral. The Nauticus shell works in that spiral. This snail shell works in that spiral. Even a caterpillar, when it curls up, runs on that spiral. When you look closely at this cauliflower, green cauliflower, they run on those spirals. So Fibonacci is everywhere. Thank you very much for your time. Cheers.